Students, this question was asked from chapter 5 of class 11, that is work energy power in the year students 2011. The question asks, a mass m is moving horizontally with velocity v collides and sticks to a mass of 3m moving vertically upwards with velocity 2v. The final velocity of the combination is how? Students, the first mass m is moving horizontally. That means it is moving along the x-axis. Okay, student? With velocity v. So we may write the velocity of the first mass m as v I cap, because we know I cap is the unit vector along the x-axis. The second mass of 3m, suppose this is m and this is 3m. 3m is moving along the y-axis and that is moving vertically upwards along the y-axis with velocity 2v. This is student 2v, and we can write in vector notation that way 2v j cap, because j cap is the unit vector along the y-axis. Okay, student? Horizontally means along the x-axis, vertically upwards means along the positive y-axis. The final velocity of the combination. What will be the final velocity? Suppose, student, this is the final velocity. Let us denote it by capital V. Then, students, how can we find out V? We will apply the law or principle of conservation of linear momentum. Okay, what is the sum of the linear momentum before the collision and after the collision? And both of them will be same according to the principle of conservation of linear momentum. Okay, student? Then what is the linear momentum of the first particle? That is mvi cap. Okay, student? What will be the initial velocity of the second particle? That is, it was given, student, 3m. This 3m mass is moving with velocity 2v. Okay. So what will be its initial linear momentum? That will be 3m into 2v j cap. Okay, student? So the final velocity is v and the final mass is this mass m sticks with the mass 3m. So the mass of the combination is m plus 3m and its velocity we have denoted it by capital V. Okay, student? According to principle of conservation, the sum of the linear momentum before the collision must be equal to the linear momentum after the collision. So, student, let us divide this equation by m. So this m will be gone, this m will be gone, and this is 4m. Okay, student, 4m, this is 4m. So this m will be gone if we divide this by m. So we are left with v I cap plus 3 into t6 v j cap is equal to 4 capital V. The question asks, what is the final velocity of the combination? What is the final velocity? That is v. That means v will be equal to this much divided by 4. So that will be equal to, student, 1 by 4 v I cap plus 6 by 4 v j cap. So we may write 6 by 4 as 3 by 2. Okay, student? So this will be the answer, 1 by 4 vi cap plus 3 by 2 vj cap. Where is it? 1 by 4 vi cap plus 3 by 2 vj cap. It is in option B. So option B will be correct, students, for this question.